Hello, hi everyone. Welcome to the student the brand. This is our Sivas. Today topic is electric current. Electric current, electric current, electric current, electric current, electric current, electric current, electric current. I equal to Q by T. I equal to Q by T. The rate of flow of charge is called. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. What is SI unit of current? SI unit of current. What is SI unit of current? SI unit of current is ampere. SI unit of charge is coulomb. Yes. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Yes. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So here I am considering, sir, why you are writing with a small letter? Ampere. 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 SI unit of current is ampere. And honoring the scientist, we are writing so small letters as a unit. And SI unit of charge is coulomb. SI unit of charge is coulomb. And SI unit of time is second. SI unit of time is second. Okay. So 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second. That is called electric current. That is called electric current. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right? So now quantization of charge. So in this conductor, this is a conductor. If only one electron flows, will you say current is flowing? Only two electron flows, will you say current is flowing? Only three electrons flows, will you say current is flowing? No, we can't say like that. So number of charges are moving in the conductor. Number of charges, number of electrons are moving in the conductor. Then only we can say current is flowing. Right? So here you can see number of charges. So either positive charge, negative charge. So we can take positive charge, negative charge are moving inside of the conductor. That's why Q equal to plus or minus any. Q equal to plus or minus any. On one electron, how much charge is present? On one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, this much charge is present. On one electron, 1.6 into 10 power minus 19 coulomb. So that much charge is present. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? We'll see. In 1 coulomb, 1 by 1.6 into 10 power minus 19, then you will get, okay, so 1 by 1.6, 1 by 1.6 into 10 power 19, 1 by 1.6 into 10 power 19. So then you can observe here, in 1 coulomb, 1 by 1.6 into 10 power 19. So if you solve this one, 1 by 1.6, 1 by 1.6, how much you'll get? 0.625. 1 by 1.6 is 0.625. Then you are removing 1 0, then you are getting like this. So here you can see 0.625 into 10 power 19. Then you will get 6.25 into 10 power 18 electrons in 1 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Very, very important. So first one, electric current. Electric current is nothing but the rate of flow of charge. or the flow of charge through unit cross section area per second is called electric current. The net charge flowing through unit cross section area per second is called electric current. Okay, simply we can say rate of flow of charge. Rate means with respect to time. Rate means with respect to time we are saying. So that's why the rate of flow of charge is called electric current. I equal to Q by T. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. Is called electric current. On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. Very, very important for MCQ's point of view. Okay, SI unit of current, ampere, and symbol we have to take capital A. Okay, so these are very, very important points. Just look at the board. Okay, so I equal to Q by T. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. So Q equal to plus or minus NE. On 1 electron, 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, 1 by 1.6 into 10 power minus 19. Then you will get in 1 coulomb 6.25 into 10 power 18 electrons are present. Yes, right. Yes. Now you can see. So now, so we can take, so that is electric current we discussed, and the SI unit of electric current, SI unit of charge, SI unit of time. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. So that is about electric current. Now electrical elements. We will discuss about electrical elements. Cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, and bulb. So these all electrical elements we will discuss now. So let's discuss. First one is cell. So positive terminal, negative terminal, then we can say cell. Second one is battery. This is a battery, positive terminal, negative terminal. So battery, I am taking battery. And third one, so switch. This is a open switch. And fourth one is closed switch. This is a closed switch. And next one resistor. Fifth one is resistor. This is a resistor. Resistor is a device. Which is used to. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is a phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is a phenomena of opposing the electric current. Okay, so resistor. Next one, sixth one we are going to discuss about rheostat. Okay, so this is about rheostat. Okay, rheostat. Okay, rheostat. Next one, ammeter, voltmeter. Seventh one is ammeter. Here is ammeter. And voltmeter. This is a voltmeter. Next one, ninth one, wire joining. This is a wire joining. Next, wire crossing, and 11th one, bulb, electrical bulb. Okay, so this is symbol for electrical bulb. Once again, you can observe cell, battery, open switch, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, ammeter, voltmeter, wire joining, wire crossing, and bulb. Okay, so now we will discuss about resistor. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device. Resistor. Okay, so first one resistor, next one resistance. Resistance is the phenomena of opposing the electric current in the circuit. And the second one, ohm. SI unit of resistance is ohm. Symbol for resistance is like this. I hope it is very clear. Understood? So once again observe, SI unit of resistance is ohm. Symbol for resistance is this one. So what exactly the resistance? Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Coming to the rheostat. Rheostat is a device which is used to regulate the current. Regulate the current without changing the voltage source. Rheostat is the device which is used to regulate the current without changing the voltage source. Without changing the voltage source. That is called rheostat. Coming to ammeter. Ammeter is a device which is used to measure the electric current in the circuit. Ammeter is a device. So here you can observe this ammeter. Ammeter is a device which is used to measure the electric current in the circuit. Okay, so voltmeter is a device which is used to measure the potential difference. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Okay, so anyway, after that electrical bulb, you know that wire joining, wire crossing, all these points we can get to know that. Now, so once again, all the points: cell, battery, open switch, closed switch. So once again, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. So now we will discuss about electric circuit. Electric circuit. So here in electric circuit, electric circuit. Okay, so now electric circuit. What is an electric circuit? A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. Okay, so now you can observe here. So I am taking this the bulb, and I am connecting to the ammeter. Here is ammeter, and so battery here. This is a battery switch. Switch is here. Okay, so I am connecting positive terminal, negative terminal, connecting to the ammeter. So past current is, the bulb is glowing because bulb is glowing like this. Okay, current is flowing. Yes or no? When the current is flowing through the circuit, automatically, so the bulb will glow. Here one thing, there are current. What is electric current? Normally the rate of flow of charge. The flow of charge through unit cross section area per second is called electric current. Here two types of currents. One is conventional current, another one is electric current. So what is conventional current? What is electric current? Conventional current is nothing but the flow of positive charges. The rate of flow of positive charges is known as conventional current. What is electric current? The flow of electrons. The flow of electrons is known as electric current. First one is Conventional current, the flow of positive charges. So conventional conventional current. And the second one is electric current. Electric current. So before finding electron, protons, everything, so already they given the statement flow of positive charges. So still we are using the same statement. The flow of positive charges is known as conventional current. So positive charges are moving from positive terminal to negative terminal. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. So here you can observe, so positive charges are moving from positive terminal to negative terminal. So like this I am considering positive charges. The positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Okay, so here conventional current. So the flow of positive charges will move from high potential to low potential. So positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Low potential to high potential. Is it possible that the electrons will move from high potential to low potential? No. Only electrons will move from negative terminal. So negative terminal to positive terminal, that is nothing but low potential to high potential. Low potential to high potential. I hope it is very clear. So this is about conventional current and electric current. Conventional current and electric current. So now next we'll discuss about electrical potential and potential difference. Electrical potential and potential difference. Okay, so potential difference. What is potential difference? So potential difference is nothing but the rate of flow of positive charges. The rate of flow of positive charges is known as, so what is the potential difference? Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Potential difference, the work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. V equal to W by Q. So just check once here. So potential difference, potential difference, potential difference, potential difference. Okay, so here you can observe, this is the conductor, this is the conductor. I am taking this is the point, this is one point, so point A, and this is the point B. So we are doing, so this is a positive charge. We are doing some work. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from one point to another point. From one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Is called potential difference. Yes or no? So V equal to W by Q. V equal to W by Q. So W, what is W? Work done. What is Q? Charge. What is V? Potential difference. Work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. V equal to W by Q. V equal to W by Q. So here you can observe. So SI unit of potential is volt. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. Coming to the electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. Okay. So electrical potential, electrical potential, electrical potential. So electrical potential. So you can observe here electrical potential work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So I am taking this the point. So this is infinity and I am taking the positive charge. So positive charge. We are doing some work. We are doing some work to bring unit positive charge. So this I am taking the field. So this is the required field. I am doing some work to bring unit positive charge from infinity to the required field is called electrical potential. V equal to W by Q. V equal to W by Q. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. So that is nothing but electrical potential. Electrical potential. Once again, potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is potential difference. So work done to bring unit positive charge from one point to from infinity to the required field is electrical potential. From infinity to the required field is electrical potential. From one point to another point within the conductor is called potential difference. V equal to W by Q. So formula is same. So the units are same. 1 volt is defined as 1 coulomb. 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, so that is called potential. 1 volt. So 1 volt. Okay, SI unit of potential difference is 1 volt. I hope it is very clear. So just check once here. So potential difference and electrical potential. Potential difference and electrical potential. Right? Now, so let's discuss about Ohm's law. So now we are going to discuss about Ohm's law. Ohm's law is nothing but Ohm's law, right? Yes. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. So now we can take V equal to IR. I equal to V by R. So R equal to V by I. R equal to V by I. Right? Yes. Now you can see materials required. What are the materials required to do the Ohm's law activity? Materials required. So now we will discuss about materials required. Materials. So first one I am taking. First one, 4 cells. 1.5 volts of each. How many cells? 4 cells. 4 cells. So I am taking 4 cells. So 1.5 volts of each. Yes. 1.5 volts of each. Okay. Second one, nichrome wire. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy. Yes or no? It is an alloy of nickel, chromium, manganese and iron metals. So second one is nichrome wire. Second one is nichrome wire. Third one is okay. So ammeter. So next one, voltmeter. Next one, switch. Fifth one is switch. Okay. And sixth one is connecting wires. Connecting wires. So understood. Once again, materials required. What are the materials required to do the Ohm's law activity? First one is 4 cells. 4 cells. So 1.5 volts of each. Second one, nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And so ammeter, voltmeter, switch and connecting wires. So now we will draw the circuit diagram. So how to draw the circuit diagram? So whatever we okay, so we wrote here, those we have to connect. First one, so I'm connecting 4 cells. These are 4 cells. 1, 2, 3, 4. Okay, 4 cells. 4 cells I'm connecting like this. And the next one, ammeter. And next one, so nichrome wire I'm connecting like this. Nichrome wire. Next one, switch. Nichrome wire switch. After that, so I'm drawing like here. Okay, so here it is voltmeter. This is the voltmeter. So here current is passing like this. Current is passing. Positive and negative. Current is passing. Positive, negative. So V is the voltmeter which is used to measure the potential difference across the ends of the metallic conductor. Okay, so voltmeter will be connected in parallel combination, ammeter will be connected in series combination. Voltmeter will be connected in parallel combination, ammeter will be connected in series combination. I hope it is very clear. So now you can check. So I'm connecting here. So like this, so ammeter current 2 and 3 and 4. Okay now. So 4 cells, 1.5 volts of each. So now you can observe procedure to do the first one. You have to connect to one cell. And note down the reading of ammeter and voltmeter. First you have one cell. So one cell you have to connect. And note down the reading of ammeter and voltmeter. Next you have to connect to 2 cells. Okay. So you have to connect to 2 cells and note down the reading of ammeter and voltmeter. So all are same only. So you can take like here. Okay. So 1, 2, 3, 4, 5. And here you can observe. So repeat the process for 3 and 4. So you have to repeat the process for 3 and 4. And what are you observed? Ammeter reading, voltmeter reading, you may have to mention in the tabular form given below. So you have to mention in this tabular form. So that is, you can observe here. So serial number of cells, ammeter reading, voltmeter reading, V by I form. Okay. So once again, 1, 2, 3, 4. So serial number of cells. So ammeter reading, voltmeter reading, V by I form, that is nothing but R. V by is nothing but R. So 1, 2, 3, 4. So 1, 2, 3, 4. How many cells are required? 4 cells. 4 cells we are connecting, right? Yes. So here you can observe once again the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature, and physical conditions also same. That is called Ohm's law. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR, I equal to V by I equal to V by R equal to V by I. Okay, so materials are required to do the Ohm's law activity. Materials are required to do the Ohm's law activity. First of all, 4 cells, 1.5 volts of each. After that, nickel wire. Nickel wire is an alloy of nickel, chromium, manganese and iron metals. Next one, ammeter, voltmeter, switch, connecting wires. Okay, so these are the materials required. Now, this is the circuit diagram. So this is the circuit diagram. Circuit diagram. Circuit diagram. Dun, 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 dun. Circuit diagram. Okay, so circuit diagram. I hope it is very clear. Just observe here. So first you have to connect to one cell and note down the reading of ammeter and voltmeter, and connect to two cells. So you have to connect to two cells and still you have to note down the observe the reading of ammeter and voltmeter. So ammeter reading is current, voltmeter reading is potential difference. Then repeat the process for 3 and 4. Repeat the process for 3 and 4. Then you can mention in the tabular form given below. So that is current, potential difference, V by equal to R. V by equal to R. Now you can observe here. So I am taking this one, the graph between V and I. So the graph, VI graph gives straight line. The VI graph gives straight line. Yes or no? So why it is straight line? Because now we are connecting ammeter and voltmeter. Okay, for one cell. So we are connecting ammeter, voltmeter. Okay, so we are taking the readings from right from first cell onwards. Right from first cell onwards we are taking. So from one cell onwards we are taking. So that's why ammeter and voltmeter reading will be 0. That's why it is starting from origin. It is starting from origin. Next you are repeating for 2 cells and taking for 3 and 4. You are taking for 3 and 4 cells, right? So then we are observing all those readings, ammeter and voltmeter, and mention in the tabular form. So VI graph gives the straight line. VI graph gives the straight line starting from origin. Okay. So the graph is linear for ohmic conductors itself. Ohmic conductors. So what do you mean by ohmic conductors? The conductors which obey Ohm's law. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. For non-ohmic conductors, what about non-ohmic conductors? For non-ohmic conductor, the graph is curved. So you can observe here, the graph is like this. For non-ohmic conductor, V on y-axis, I on x-axis, the graph is curved. The graph is curved. So the graph is curved for non-ohmic conductors. So what do you mean by ohmic conductors? What do you mean by non-ohmic conductors? Ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. For ohmic conductors, the graph is straight line starting from origin. So here also the graph is curved for non-ohmic conductors. Once again, Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature, and physical conditions also same, but constant temperature compulsory. Okay, and the next one, materials required. What are the materials required? 4 cells, 1.5 volts of each. So how many cells are required? 4 cells. So 1.5 volts of each. Second one, nickel wire. Nickel wire is an alloy of nickel, chromium, manganese and iron metals. So that is second one. And the next one is ammeter. Ammeter is used to measure the electric current connected in series combination. Ammeter is a device which is used to measure the electric current will be connected in series combination. Coming to the voltmeter. Voltmeter will be connected in parallel combination. Voltmeter is used to measure the potential difference. Potential difference. I hope it is very clear. Next one, switch. After that, connecting wires. Okay, na? So battery we can take, that is cells we can take, cells only, right? Battery. Okay, so first, after the procedure, what is the procedure? First you have to connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. Ammeter reading is current, voltmeter reading is potential difference. After that, connect to two cells and note down the reading of ammeter and voltmeter, and repeat the process for, and repeat the same process for 3 and 4, and mention in the tabular form given below. So you have to mention in the tabular form. Okay, so if you draw the graph for vi, okay, v and I, that is nothing but potential difference and current. The graph is straight line starting from origin. The graph is linear. The graph is linear for ohmic conductors. The graph is linear for ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So here you can see, the for non-ohmic conductor the graph is curved. Okay, so this is about Ohm's law. Okay, so next one we will discuss about resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Resistance and resistivity. So now you can see here. Now you can observe. So what we are discussing resistance and resistivity. Resistance and resistivity. Resistivity. So I mentioned in the earlier. Okay, resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. So now you can see R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So now you can observe here rho equal to R. SI unit of. So resistance depends on temperature. Resistance depends on temperature. Resistance depends on metal of the conductor. Resistance depends on metal of the conductor. So here coming to resistivity, so rho equal to RA by L. Rho equal to RA by L. So resistivity is equal to. So by seeing the formula, we can tell the definition. So it's very, very important. You have to observe the formula. By observing the formula, we can get the definition. Once again, observe here. Resistivity is equal to resistance of the conductor per unit length and unit cross section area. Okay, so resistivity is equal to resistance of the conductor per unit length and unit cross section area. So if you divide like this, then you will get easily R by L into A. Okay, resistance of the conductor per unit length and unit cross section area. Okay, so that is the resistivity. Okay, so SI unit of resistivity is very, very important. SI unit of resistivity. Definitely 2 marks question. So 2 marks question is very important. Just check once. So rho equal to RA by L. So SI unit of resistivity is ohm. SI unit of area is meter square. SI unit of length is meter. So can we cancel it? Meter get cancelled. Rho equal to ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. I hope it is very clear. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Sorry. So R is directly proportional to L by A. R equal to rho into L by A. Resistance depends on temperature. Resistance depends on material of the conductor. And here you can observe resistivity. Resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. R rho equal to R by L into A. R by L into A. Now you can observe here SI unit of resistivity is very important. SI unit of resistivity is very important. So definitely expected question. Definitely expected question. So 2 marks expected question. Okay, so that is rho equal to ohm meter. Rho equal to ohm meter. So understood. So this is very important. Next one, resistivity depends on temperature and resistivity also depends on material of the conductor. Resistivity also depends on material of the conductor. I hope it is very clear. Just check once here. Just check once. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Resistance depends on temperature. Resistance depends on metal of the conductor. And resistivity rho equal to R A by L. R by L into A. So SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter, meter get cancel. Then SI unit of resistivity is ohm meter. So resistivity depends on temperature, resistivity also depends on material of the conductor. So very important 3 marks question. So all are very important. Make sure that you are learning these all points, because it will be helpful, it will be useful. Definitely each and every formula, each and every definition is very important. So the especially difference between resistance and resistivity, so both are very important. Make sure that you are practicing these points. So that is resistance and resistivity. Okay, so next one we will discuss about resistors are connected in series combination. Next, resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in series combination. Then and resistors are connected in parallel combination. Okay, so we will discuss all these points. So first point is resistors are connected in series combination. Yes or no? Resistors are connected in series combination. So now you can see, so 1 and 2 and 3. Okay, so these are 3 resistors, R1, R2 and R3. R1, R2, R3. Across R1 I am connecting V1, across R2 I am connecting V2. So R1 V1, here R2 V2 and here R3 V3. Across R1, so across R1, across R1 V1, across R1 V1, across R2 V2, across R3 V3. Okay, so now you can observe here, so those 3 resistors are connected in series combination. Those 3 resistors are connected in series combination. So here you can observe, okay, so 1, 2, positive terminal, negative terminal, current is flowing. Okay, so current is flowing, and here now you can observe one thing. In series combination, current is same throughout the circuit. In series combination, current is same throughout the circuit, but potential difference is different. Across R1 V1, across R2 V2, across R3 V3 we connected, right? But current is same in the series combination of the circuit. Okay, so that from Ohm's law, V equal to IR, IR. V equal to IR. IS equal to I1 equal to I2 equal to I3 equal to I. Okay, I1 equal to I2 equal to I3 equal to I. So why? Throughout the circuit current is same. Throughout the circuit current is same. Throughout the circuit current is same. So that is nothing but Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So that we can write IRS equal to IR1 plus IR2 plus IR3. So I am taking I common. So shall I take I common? I am taking I common. So you can observe I am taking common. Then if you are taking I common, R1 plus R2 plus R3. So I get cancelled. I get cancelled. The remaining values are RS equal to R1 plus R2 plus R3. So resistors are connected in series combination. Resistors are connected in series combination. If resistors are connected in series combination, so simply you have to add all the resistance. Simply you have to add all the resistance. Resistors are connected in series combination. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, RS equal to NR. RS equal to NR. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, RS equal to NR. So normally here one point. Okay. So in series combination, the physical quantity which is constant in series combination, the physical quantity which is constant in series combination is what? The physical quantity which is constant in series combination, that is current. Okay, so throughout the circuit current is same. Throughout the circuit current is same. So that's why the physical quantity which is constant in series combination is I. That is nothing but current. Okay, current is a physical quantity. Right? Now, so potential difference anyway it is different. Potential difference is different. Okay, across R1 V1, across R2 V2, across R3 V3. Potential difference is different. So current is same. So they will ask in the exam which physical quantity is constant in series combination. Okay, that is current. So which physical quantity is constant in parallel combination? That time I will explain. So just watch the video. Okay, so automatically you'll get to know. Next concept is that only. Okay, now resistors are connected in parallel combination. Now resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay, observe here. Resistors are connected in are connected resistors are connected in parallel combination parallel combination okay, resistors are connected in parallel combination. So now you can observe here. So I'm connecting three resistors. One. So next one 2. Next one 3. Okay. So ammeter. And here also battery, switch, So positive terminal, negative terminal, current is flowing R1, R2, R3 across R1. So this is R1, R1, R2, R3. So here across R1, R2, R3 we am connecting potential difference. We am connecting like this. Okay. So current is passing. So I, here is I, and here also I. Okay. So across R1 I am connecting. So current is passing, right? So I1 across R1, I1 across R2, I2 across R3, I3. Okay. So across R1, I1 across R2, I2 across R3, I3. So current is dividing into three parts. Current is dividing into three parts. So here the physical quantity. So the physical quantity which is constant in parallel combination is potential difference, because across R1, R2, R3 V is constant. V I am connecting same, right? So potential difference is same. Potential difference is same. But current is dividing, right? Current is dividing into three parts. So here you can observe from Ohm's law V equal to IR. From Ohm's law V equal to IR. I equal to V by R. I equal to V by R. So potential difference is same, right? So potential difference same. So then Vp equal to potential difference in parallel combination. Potential difference in parallel combination. So I am taking like that. So Vp equal to V1 equal to V2 equal to V3 equal to V. Okay. Potential difference is same. Potential difference is same. Right. Now you can see Ip equal to I1 plus I2 plus I3. Ip equal to I1 plus I2 plus I3. Understood or not? So across, so your current is flowing, it is dividing, right? V by Rp. V by Rp equal to V by R1 plus V by R2 plus V by R3. Yes or no? So V is common, right? V is common. Shall I take V common and cancel it? So I am taking V common and I am cancelling the V term. So just check once. So V I am taking common 1 by Rp equal to, so we am taking common 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so so I am cancelling. So both sides, left hand side and right hand side. So then 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, only 3 resistors you connected in parallel combination, so you got it like this. If n number of resistors are connected in parallel combination, then you can see, so 1 by Rp equal to n by R. So Rp equal to R by n. Rp equal to R by n. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. So once again check here. So R1, R2, R3. So R1, R2, R3, those 3 resistors are connected in parallel combination. So potential difference is same through across R1, R2, R3. So that's why Vp equal to V1 equal to V2 equal to V3 equal to V. But current is dividing into 3 parts, I1, I2, I3. So we know from Ohm's law V equal to IR. From Ohm's law V equal to IR, I equal to V by R. So that's why Ip equal to I1 plus I2 plus I3 plus so and so on. If you connect the number of resistors, it will be there. So until, so we can, so here now I connected only 3 resistors. That's why, so Ip equal to I1 plus I2 plus I3, because so current is dividing into 3 parts. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So V I am taking common, V will get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now you say Which physical quantity is constant in parallel combination? Which physical quantity is constant in parallel combination? Potential difference. Which physical quantity is constant in series combination? Current. Okay, so in series combination, current is the physical quantity which is constant. In parallel combination, potential difference is the physical quantity which is constant. Okay, so I hope it is very clear. So there in series combination, current is constant. In parallel combination, potential difference is constant. Okay, so and SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor, that is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Okay, so these are the points. So difference between resistance and resistivity, electric circuit and the electrical elements, and resistors are connected in series combination, resistors are connected in parallel combination. Now we will discuss about heating effect of electric current. Heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. Okay, is called heating effect of electric current. Okay, so V is directly proportional to I. V is directly proportional to I. So V equal to W by Q. V equal to W by Q. W equal to V into Q. V into Q. So power is nothing but rate of doing work. P equal to W by T. W equal to VQ by T. So Q by T is current. So what is Q by T? Q by T is electric current. Q by T is electric current. Okay. So I equal to Q by T. Now you can observe here. So P equal to W by T, P, VQ by T. So P equal to V into I. Okay. So now we can take E equal to energy is given to the conductor P into T. P into T. Whatever the energy that will be converted in the form of heat. H equal to VI into T. VI into T. V equal to IR. We know that. V equal to IR. Substitute V in the place of V. Okay, then you will get H equal to IR into I into T. IR into I into T. Then you will get H equal to I square RT. I square RT. Heat produced in the conductor is directly proportional to square of current and directly proportional to resistance and directly proportional to time. Okay, so heat produced in the conductor is directly proportional to square of current, directly proportional to resistance, directly proportional to time. Okay, so this is about heating effect of electric current and also known as Joule's law of heating. What is the definition of heating effect of electric current? The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. So heating effect of electric current is also known as Joule's law of heating. I hope it is very clear, right? Next one, we can see electric short circuit. The direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the main. Okay, so it leads to the firing. And the next one, so we can take overloading. Overloading is nothing but heavy voltage appliances, high voltage appliances on at a time, then heavy amount of current will be drawn from the mains. Then it leads to the short circuit. it may leads to the short circuit. Okay, so that's enough. This is about electric current. And so related to this one, we need to discuss few problems. Okay, so let's try to do the discussion of electric current problems. Okay, so I'll write, just to try to solve it. So very important problems. Okay, so especially in the exam, these questions will be helpful. Okay, these questions they will give definitely. So the type of questions we need to practice. So those only we are doing right now. Just try to solve it. So if you like the content, if you like the explanation, if you like the channel, please do like, share and subscribe to Student D Brand. Okay, so question I am writing on the board, try to solve it. A copper wire a copper wire of resistivity a copper wire of resistivity a copper wire of resistivity is given, that is 1.6 into 10 power minus 8 ohm meter. Okay, has a cross sectional area of 20 into 10 power minus 4 centimeter square. Calculate the length of the wire. Calculate the length of this wire. Required to make so a 10 ohm coil. Okay, so 10 ohm coil. So this is the question. Just try to check the question. Resistivity is given and area of the cross section is given, and next length we have to find out. Length. Can you try to solve this question? How to solve? First one, identify the given data. So first one, copper of resistivity is 1.6 into 10 power minus 8 ohm meter, and cross sectional area is given. Calculate the length of the wire. So we need to find out the length. Okay, so now you can see under 10 ohm coil, here also they given 10 ohm coil. Okay, first write the given data. First you have to write the given data. Okay, so given data. So given data, first one, resistivity equal to 1.6 into 10 power minus 8 ohm meter. So you have to understand, you have to identify the units. So by identifying the units, you can get to know which quantity is given. So first one. Second one, area of the cross sectional area is given. And here you need to understand one thing. So we have to check whether units are there in SI system or not. Okay. So they given in centimeter. Centimeter must be converted into meters. Okay, we know that 1 meter equal to, so this conversion, note down this conversion, 1 meter equal to 100 centimeter. So 1 centimeter equal to 10 millimeter. Okay, so now you can observe here they given 20 into 10 power minus 4 centimeter square. 20 into 10 power minus 4, that is area of the cross section. So 20 into 10 power minus 4 centimeter square. Okay, 1 centimeter. Here 1 centimeter equal to 1 by 100 meter. That can be written 1 centimeter equal to 10 power minus 2 meter. So square on both sides. 1 centimeter, so better you can write centimeter. So centimeter square equal to 10 power minus 2 whole square and meter square. Then you will get centimeter square equal to, okay, so that is 10 power minus 4 meter square. Okay, so in the place of centimeter square, simply you can substitute 10 power minus 4 meter square. Okay, so if you substitute area equal to 20 into 10 power minus 4, again 10 power minus 4 into meter square. Okay, then if you write a power m into a power n, so a power m plus n, so if you add all these things, so a power m into a power n equal to a power m plus n. So if bases are same, you have to add the powers. So we are adding all those things. Now you can take, so 20 into 10 power minus 8 meter square, that is area of the cross section. Area of the cross section. I hope it is clear to you. Yes. So now you can observe. So resistivity is given, area of the cross section is given, resistance. Resistance is how much? R equal to 10 ohm. 10 ohm. So now we know the formula. What is the formula? So R equal to rho into L by A. So this is the formula. Okay, now you can observe. We know R we know rho. So rho already given, and A also we just now we solved it. So we got A also. Now we want to find out the length. So we need to find out the length. We have to find the length. Okay. So take the length formula from this equation. That is L equal to RA by rho. L equal to RA by rho. Yes. So this is the formula. L equal to RA by rho. Now substitute all the values. So 10 into a 20 into 10 power minus 8 rho. So 1.6 into 10 power minus 8. Okay. So anyway, this calculation you know that. So that's why I'm erasing this calculation. Okay. So anyway, this formula you know, right? So I'm erasing this one and this calculation also, and up to here. Now see this formula, that is L equal to RA by L. So now R equal to how much? R equal to 10. So how much R value? 10. And area of the cross section how much? 20 into 10 power minus 8 by L value how much? L value, sorry, this is rho, right? This is not L. Already we want to find out L only, right? So this is rho. Rho value how much? Rho equal to 1.6 into 10 power minus 8. Okay. So here same values we can cancel it. This value we can cancel. So 200 by 1.6. So still we can cancel it. 2000 by 16 how much? So just you can find out. So if you want to remove the value, 200 by 1, so 10 by 10 you can do it. Then 2000 by 16, then you will get 125. So is it correct or not? Let me know the answer. 16, then you will get 125. So what are the values we converted into SI unit? then that is L equal to 125 meter. Is it correct? Is it wrong? Or so let me know. So did you get the same answer? So L equal to 125. Okay, done. So next, one more problem. So current is not following vector law of addition. So it is a scalar quantity. Okay. So now one more question. So this is very important question. Very favorite question. So I'll write on the board. Just try to solve it. Okay. If you like the content, if you like my explanation, if you like the channel, please do like, share and subscribe to Studying the Brand. So I'll get more updates, you'll get valuable content. Okay. So try to join to the class whenever live is going on. So a current. So for that what you have to do, you have to subscribe my channel, click on like bell icon, then automatically you'll get the updates. And so just while you are in live class, please click on like button, then it will be so automatically it will reach to the remaining students also. Those who want to learn, then automatically this will helpful for them to learn physics, and directly you are helping them. Okay. And one more point, so please subscribe and share to your friends, ask your friends to join to the class, so let them know about this class, about Studying the Brand channel. Thank you so much for joining, thank you so much for attending, thank you so much for supporting, thank you so much for subscribing, and inform your friends, ask your friends to join to the class. Thank you. So a current of 500 milliampere, 500 milliampere flows in a series combination, in a series circuit, in a series circuit containing, okay, so here you can observe, containing an electric lamp, an electric lamp, an electric lamp, an electric lamp, and a conductor, and a conductor, and a conductor, okay, of 10 ohm, 10 ohm. So when connected to when connected to 6 volts battery, 6 volts battery, so find the resistance, find the resistance, find the resistance of the electric lamp, electric lamp. So can you let me know the answer? Electric lamp. This is the question. Check once. So I'm giving time. So 4 minutes time to do the problem. So 4 minutes time. 4 minutes time for calculating the problem. So try to solve. After that I will calculate. So I will explain the problem. So yes, correct. So most of the students said the right answer. So see, when you are seeing this type of problem, first you have to identify the given data. So first you need to identify the given data. So that is very important. Okay. So when you are solving physics problem, identify the given data. So here they given the current is nothing but I, flows in a series circuit containing an electrical lamp, so resistance of the lamp, and a conductor RC, resistance of the conductor connected. So here conductor, okay, so conductor resistance how much? 10 ohm. So when it is connected to a battery, potential difference is given. Find the resistance of the electrical lamp. Resistance of the lamp we want. Okay. So now write the given data. First write the given data. Okay. So given data. So given data. What is the given data? First of all, current. What is the current? Current is 500 milliampere. 500 milliampere. 500 milliampere. 1 ampere. So milliampere is nothing but milliampere equal to 10 power minus 3 ampere. So very important. Milliampere equal to 10 power minus 3 ampere. So you have to understand that one. So after that you'll get, so 500 into 10 power minus 3 ampere. So that is current. Coming to the second one, resistance of the lamp we have to find out. RL we have to find out. But RC given, resistance of the conductor how much? RC equal to 10 ohm. Okay, and connected to a battery, potential difference is given how much? 6 volts. Potential difference is given how much? 6 volts, right? So 6. We know V equal to IR, basic formula. So we have to take from the basic formula. Okay, V equal to IR. V equal to IR formula if you take. Okay, so V equal to IR. V equal to IR. So V equal to how much? 6. And I, we have to, I, they given, right? I equal to 500 into 10 power minus 3. And so instead of R, we have, here they given resistance of the conductor and resistance of the lamp. Resistance of the conductor RC plus RL, right? So directly I am writing, okay, so one more step I'll write. We need to understand right here. So 500 into 10 power minus 3. So again RC how much? Resistance of the conductor 10 plus RL how much? We need to find out RL. Okay. So now you can take this value down. So 6 by 500 into 10 power minus 3. You'll get 10 in 10 plus RL, resistance of the lamp. So with 10 power minus will goes up 6000 by 500 equal to 10 plus RL. Okay, so we can cancel. Shall we cancel 2 zeros? 2 zeros get cancelled. 5 12 60. So then 12 equal to 10 plus RL. Then from that RL equal to 12 minus 10. Then you will get RL equal to 2 ohm. RL equal to 2 ohm. Okay, this is the answer. Okay. So did you get the same answer? So most of the students are mentioned in the comment section. So 2 ohm, very good. So keep it up. This is the answer for that. Okay. So very important. Just observe the data, observe the given data. Then so write one side. Then check the all units. First you have to check all the units whether they given proper or not. After that, which formula is suitable for the given data. So we must check which formula is suitable for the given data. So this is the formula. V equal to IR. Okay, so we know we know many formulas, but which formula is required for the given data, that you have to mention. V equal to IR. From that we have to substitute all the values, then you'll get the answer, final answer. Okay, so that's enough. This is about one more problem. Next, so we will see resistors are connected in series, resistors are connected in parallel combination. Okay, so now we will check one more problem. So I'll give one more problem. Try to solve it. Mm. So here now it's very important, very important. So try to solve this one. Try to solve this one. 3 2-ohm resistors. So question number 1. Oh, so this is the third question. 3 2-ohm resistor, 2-ohm resistors, 2-ohm resistors A, B and C are are connected in such a way, in such a way in such a way that the total resistance the total resistance the total the total resistance of the combination total resistance of the combination okay total resistance of the combination is 3 ohm is 3 ohm. So show the arrangement 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 of the three resistors arrangement of the three resistors and justify your answer. Okay, justify your answer. Okay, so this is the question. Try to solve it. Okay, so try to solve this question. Maximum based on this type of questions only they will ask. Okay, so expected for 3 marks like that. Okay, just check once. Okay, just try to solve it. So here you can observe, so 3 2 ohm resistors A, B, C, three 2 ohm resistors are connected in such a way that total resistance of the combination is 3 ohm. Show the arrangement. So we have to show the arrangement. So actually 3 ohm, 2 ohm resistor. So 1, so next 2, next 3 like this, 2 ohm, 2 ohm, 2 ohm, like that 3 resistors. So we have to connect in order that to get 3 ohm resistors. So now if you connect all 3 in series combination, so 2 plus 2 plus 2 will get 6. So wrong. If you connect all 3 in parallel combination, 1 by 2 plus 1 by 2 plus 1 by 2, then 2 is common, 1 plus 1 plus 1, so that is 1 by Rp. Rp equal to, so I'll get 2 by 3. So that is also wrong. We won't get it. If you connect 3 resistors in series, you won't get the answer. If you connect 3 resistors are in parallel, you won't get the answer. So you have to try for different combinations. Okay. So we need to connect in different combination. So here only 3 are there. So that's why I'm connecting 2 in series. No, it is not possible. So 2 in series, 1 is parallel also. If you try, so 4 1 by 4 plus 1 by 2, there also won't get. So now I'll try 2 in parallel combination like this, and 1 in series combination. 2 in parallel combination, 1 in series combination. If I connect, how I will get, you can check once. So I'm connecting like this. So remaining in series combination, 2 ohm, 2 ohm, and 2 ohm and 2 ohm here. Okay. So if I connect in such a way that, then you can observe here. Okay. First you take this 2. So 1 by 2, 1 by 2 plus 1 by 2, that is 1 by Rp. Then 2 by 1 plus 1, that is nothing but 2 by 2. Then Rp equal to 1. Okay. So resultant combination is 1 you are getting. So and here is 2. So 2 plus 1, then you will get 2. So 2 plus 1 is 3. So total combination you are getting 3 ohm. That is the correct answer. This is the correct combination. You have to check. So if they give this type of questions, first you have to check how much they given resistance. So 2 ohm is given. So you can observe, I verified like this. So I verified like this. So 3 resistors. If I connect 3 on series, 2 ohm plus 2 ohm, 2 ohm. So we can't get 3 ohm. If you connect 3 are in parallel combination also, you won't get it. So you have to go for different combinations, right? So I followed. If you follow different combination also, you can check, no problem. Okay, you have to check. So when they will give this type of questions, so trial and error method we have to follow. Trial and error method, whether you are getting or not. So while you are practicing time only, you have to do it. So during exam, if you do, you won't get it, right? So it will take time. Then again you lose the time. So no use. You'll get frustration if you are not getting the correct answer. So that's why, well, this type of questions you need to practice. You have to practice. You should get practice before going to attempt the exam. Okay, before going to write the exam, you need to practice. Then only in the exam you can think fast. Okay, so directly by saying that one, instead of writing, instead of solving that, so you can calculate in our mind. So 2 ohm, if you connect 3 in series, so you won't get it. So 6. If you connect in parallel, that also like that. You can think fast, then automatically you get the correct method to attempt this question. Okay, this type of questions. So be careful, practice many times, many models. So you will get so many models, like 100 different questions. Okay, so like related to electricity, like you'll get notes, 100 different problems, and models, different models are there. So based on different models, 100 problems are there, and you'll get notes of 4 chapters: light, reflection and diffraction, human and color fluid, electricity, magnetic effects of electric current. And these 4 chapters notes and you'll get 100 definitions from these 4 chapters. Definitions are very important, like reflection, refraction, refractive index, absolute refractive index, and after that critical angle, total internal reflection, human eye, parts and function, myopia, hypermetropia, after that cataract, like that. So many definitions also you'll get. So 100 definitions. So I wrote all these no, like a notes, handwritten notes. So you'll get for 100 rupees. So those who want, you can contact to that number. Okay, if you like the content, if you like the channel, if you like the explanation, so do like, share and subscribe to Studying the Brand. So click on bell icon. Whenever I'm taking live classes, you'll get notifications. So based on CBSE grade 10 physics, continuously we are taking live classes. Definitely concept will be explained in depth, and based on that one, so I will I will give some questions also like this. So how I given related to physics, like electricity problems, same thing based on remaining chapters also I'll try to give the questions. So try to follow, try to subscribe, try to like, share and subscribe my channel. So subscribe, definitely you'll get concept, definitely you'll get benefited by subscribing the channel. Definitely you'll get good content. Okay, so better content and important questions also I'll let you know. While I'm explaining only, I will tell to you. So these questions are very important, these concepts are very important. So here you need to concentrate, there you have to focus more, here you have to practice more. These type of questions they will ask, so we have to answer like this. Everything I'll explain in this live classes. So live classes are going on continuously. Try to do like, share and subscribe to Studying the Brand, and inform your friends, ask your friends to join to the class. Share as much as possible, as many as possible, ask them to join to the class, attend the class, listen the class. Then definitely they will get good content, okay, from the channel. So this is your sir from Studying the Brand. If you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Studying the Brand. So we'll see in the next class. Thank you so much.